All right, so now that we have seen how to derive the quadratic equation, let's just try and use it. So this is what you're going to be doing mostly. You're not going to be deriving it. You'll not be asked to go through that process that I explained over the last 10 minutes, but you will be expected to use it for sure. So let's use it in this example number 1, where we're going to have real roots and where c is positive. So the context here is a contest where at the World Championship Pumpkin Chunkin Contest, pumpkins are launched hundreds of yards. The path of a pumpkin can be modeled by h equals negative 16t squared plus 124.4t plus 42. So if you pause there and think, which way should this parabola be facing? Should it be facing upwards or should it be facing downwards? Well, you'd look at your A term there, that negative 16 at the front, and that would be telling you that you have a downwards facing parabola, which would make sense. We're talking about projectile motion here, things that go up and come back down, like a pumpkin being launched. So that should kind of fit the scenario. H in this equation is the height in feet, and t is the number of seconds after launch. So we are picturing something like this on a graph. We have a graph where our variable is time. As time passes on, this object gets launched up in the air and it comes back down. So this stuff underneath the x-axis probably won't relate to this question too much because we're picking the x-axis. We're going to call that ground level. Okay, so maybe we're going to lose these parts here. Okay, now why did I put those two roots where I did? Well, let's take a look at the equation here. In our equation, what would happen if we looked at time equals 0 seconds? So time equals 0 seconds right here. Why did I expect that it should be up here to begin with at 0 seconds and not down here at the bottom? You can see that question in that think about it on the bottom right of the screen right now. Why are the roots not at 0 and 8.1 seconds? Why is one of the roots not at 0? Well, if you look at that equation, you'll see that if we put in 0, the first term of the equation disappears. Negative 16 times 0 squared would disappear. Plus 124.4 times 0 would also disappear. So the A term and the B term would both go away, and all we'd be left with would be 42, which means that we can assume that in my drawing, we should be labeling this right here as 42. Okay, now if we follow along on the example, it's all pretty straightforward here. And let's walk through that real quick. So we have our equation, and we are going to plug in some values. So we'll plug in our B value first, which is that 124.4. We'll put it into any place with a B, so B squared shows up right about there. Minus 4AC. Well, our A term is negative 16. Our C term is 42. And on the bottom, we put our A term again in that 2A. Okay, simplifying that down, we take our square of 124 and we get 15,475. We simplify everything over here to get plus 2,688. On the bottom, we get negative 32. So inside the square root, we end up with about 18,163. Now, keeping in mind, when you take the square root of a number, you get a positive and a negative value. So remember, that's why we have that plus or minus sign right in there. Now, the square root of 18,163 on my calculator looks to be about 135, just about 135 or so. So we have 124.4 plus 135 and 124.4 minus 135. Okay, so let me try that real quick. I'm going to add those numbers together, 124.4, and I get 259. Okay, so I'm going to divide that by 32 to find our first root. And indeed, it is 8.1 seconds. Okay, so that is going to be out on the right. Our other answer would be where we subtract that square root. So we would take 124.4 and we would be subtracting whatever I just got from there, 135 or something, a number that was bigger than 124, right? So we would end up on that second answer for our roots with a negative answer. Okay, let me figure that out so that we can actually put it on our graph. So once again, we're going to be taking the square root of 18,163.36. Once we have that square root, which was 134.7, we can say 124.4 minus 134.7 and divide our answer by 32, which gives me negative 0.32. So my drawing is not great to scale, but gets the point across with a negative 0.32. Okay. So this pumpkin must have been launched at a height of 42 feet, right? We're assuming that this portion of the graph on the left doesn't really mean anything because we would assume that we were measuring this situation where at time equals 0, as in the question says, where t is the number of seconds after launch. So if you were 0 seconds after launch, that means at time equals 0, that is where you're launching. So we can kind of remove this, and our final picture is a situation that starts at time equals 0 seconds up at 42, and it goes to time equals 8.1 seconds down at a height of 0 where it hits the ground. Okay.